Thank you to all of the Isaac Science, previously Isaac Physics users for helping us to reach 200 million question attempts on our site. A fantastic milestone, and we are delighted to be celebrating that. The question that has hit the 200 millionth mark is this question here about circuits, and it's from our GCSE physics book, and we're going to talk you through today how to solve this problem. The physics that we're going to use here is actually a type of physics that's quite common to answering questions, and that's the idea of conserving things. We're going to be conserving charge here, and the way we're going to think about that is by looking at the current. So a current is a charge per unit time passing past a point, and so we've got 3 amps in this part of the circuit here. And what we know is as we move around the circuit, we can't lose or gain charge. We have to conserve that charge per unit time as we go around the circuit. And conservation laws are prevalent throughout physics. And so as we come to this resistor here, we've got 3 amps coming into the resistor, and we can't gain or lose any charge or current along the way. So we must have 3 amps at this point P, and then we go through another resistor, and again we can't gain or lose any charge, and so we must have another 3 amps coming around the circuit here, going all the way back to the cell that's providing the charges in the first place. Now in part B, the idea is that we extend this idea and test our understanding of this concept of conserving charge and therefore conserving current. This was actually a law that was brought together by Kirchhoff. It's called Kirchhoff's current law. And so this time we've got 3.5 amps coming into this resistor. So in this part of the circuit, same idea as before, we know we must have 3.5 amps. But this idea of conserving charge and conserving current, when we come to a junction, this is what Kirchhoff's current law said. The sum of the currents coming into the junction must equal the sum of the currents coming out. So we have 3.5 amps coming in. That must be equal to 2.0 amps plus what we want for P. And so 3.5 minus 2.0 gives us the value of the current at P, which is 1.5 amps. So if this has motivated and whetted your appetite to try questions in maths, physics, chemistry and biology, then visit the Isaac Science site. You can find the link in the comments. Isaac Science, previously Isaac Physics, now covers maths, biology, chemistry as well as physics. And I look forward to recording the next video, maybe in just a few weeks' time when you've answered 100 million more.